Let's begin by creating a brand new pattern library and define from scratch our first pattern for it, which will be a capacitor. Start the program, Pattern Editor. DipTrace ships with a large number of predefined libraries. In fact, they've got so many libraries, they've got libraries for different categories of components. If you want to see a library just for general components, these are thousands, well, hundreds anyway, of different types of pre-made surface mount devices. This is where you'll find pre-made versions for all of your dual inline package ICs. They've got many different categories. So with all these predefined components and libraries, why should you bother making your own? The reason you want to define your own library parts, well, there's two of them. The first is that it makes it much easier to organize your materials. If you have a single library, it's just your own, it has every part that you need for a project, you know where everything is. The second issue is that you can't guarantee that a part that's predefined by the DipTrace library will be there in the next DipTrace revision. So by creating a customized library of all your parts for every project, you know where every part is, and you also know that they're there. So let's start off by creating a brand new library to hold all of our parts in. We'll call it Entrepreneurship class. You can give it the same hint, and it's going to consist of user patterns. Notice how it's appeared up here. You can switch between the predefined libraries, choosing libraries up here, and here are all the different types of libraries. We've got to save our entrepreneurship library. You can switch between the predefined libraries up here, that these are under patterns. These are all the different major libraries that come shipped with DipTrace, and your user pattern library. You could conceivably have many different pattern libraries, one for every different project you create, and that's how I suggest you do it. Right now, the Entrepreneurship class library has nothing in it except for one default untitled component. Let's fill it in with a capacitor. When you're creating these, begin by downloading the datasheet for every unique pattern you're going to use. That is, for every unique footprint. Here's the one for the capacitor. So the body of this is 4 millimeters wide. It's 2.5 millimeters thick. And the wire leads are separated by 5 millimeters. And hopefully someplace they'll tell us how thick they are. Oh, there they are in very tiny letters, 0.5 millimeters. So those are the four key numbers: body outline size, pad separation, and wire thickness. I'm going to first copy these measurements down so I don't forget them. If they were appearing as a pattern on a printed circuit board, they'd have a 4 millimeter wide body. This dimension would be 2.5 millimeters, and we'd have pads out here separated by 5 millimeters. And last, the wire diameter is 0.5 millimeters. All right, converting that to inches, 0.157. You just need 3 significant digits for these. Are 2.5 millimeters, is 0.098. We're going to call that, 0.1. 5 millimeters, 0.197. I'm going to call that, that's pretty darn close to 0.2 inches. And then our very fine wire size is 0.2. Okay. Armed with this, we're ready to create our components. When you start the DipTrace pattern editor, this pattern properties box will always be visible. You can minimize it, but you can't remove it. These patterns that you build will appear down here. Let's start off by giving it a name. We'll call this the name of the capacitor, and this particular one is a TDK FG28 capacitor. Now this capacitor we were using in a bunch of different sizes. In this footprint, if it was available as a 1 microfarad and we were using also a 2.2 microfarad and several others, I'd keep it as this. For this particular project, we've only got one size capacitor in this footprint, and that's a 1 microfarad. So I'm going to call it exactly what it is, 1 microfarad TDK FG28. Its reference designator, that means the first letter. The number after it will be automatically given, but let's call it C. Most capacitors begin with C. And we can leave everything else blank. This pattern template will make our life a lot easier. Although you could individually draw this pattern over here, this being from the silk screen, these being with copper pads, it's a whole lot easier choosing lines. And now we can say we have just a single line of parts. We have a single line of pads. There's only 2 of them. And the pad spacing, what did we determine from over here? They're 0.2 inches apart. Man, that's easy. Line spacing doesn't affect this. If we had multiple lines over here, like a dip IC might have 2 lines. They'd be separated by 0.3 inches, which is the standard dip spacing. So now this is our early device. Looks kind of small. I'm going to zoom in a little bit here. I don't know why, but the default zooms always seem small to me. You can create pads very quickly using these pattern templates. These pads will always be drawn as copper on the copper layer. You can tell that they're copper because of their color, that light yellow color. If you wanted to, you could go about it the long way by clicking this tool up here to place a pad. Of course, then every single pad you'd have to measure out and separate by the correct amount. That would take quite a while. To get rid of pads you don't want, click your selection tool and press delete. Alright, so let's talk about how to create a silk screen in the middle to represent the body of this capacitor. When you want to use a silk screen body outline, always place it on the top silk screen. Your component can be placed on the top or the bottom of the board, and the right thing will happen. For your silk screen, when you're defining the component, always place it on the top silk screen. There's a number of drawing tools you can use with a silk screen. You can draw rectangles. You can draw filled rectangles. That's filled with paint. That's filled with this silk screen, which is usually white paint. You can do circle outlines. You can do filled outlines. For all these choices, realize that this is just a silk screen. All you're doing is you're painting in non-conductive paint. For this case, we're going to want to use the unfilled rectangle. We place it, and now we will choose the arrow tool, right-click, and put in our points. So over here it says that the body should be 0.157 wide. Well, since we're doing it evenly, that means it should be half of 0.157, which is 0.078. X values will be 0.078, 0.078. Okay, and as we updated them, you can see it's longer. How wide should it be? 0.1 inches? So I think its default might be correct. Yeah, it's from 0.05 to minus 0.05, so that's correct. All right. The next step is to realize that this silk screen is over the pad, and that means something's going to win, something's going to lose. We don't want to have paint over your pad because that'll obviously prevent you from soldering well to the pad. So we can cut down the size of our body, of our outline, of our capacitor without any problems, because the only purpose of this outline is so we don't place other components on top of it or too close. But with the way the pads are placed outside the body of the component, we couldn't place another component in the middle of this if we wanted to. So shortening the length of the silk screen of the body of this component is perfectly fine since there's no danger of putting another component in lengthwise, since it would interfere with the pads. Speaking about these pads, we want to get them sized right. Now he said, I'm going to right click, choose Properties. It is the through hole. It's an ellipse. What size hole do we need to make? Well, it says over here a 0.02 inch hole. Now, if you make the hole exactly 0.02 inches, you'll have a problem because the hole will be 0.02 inches, but then the inside of that hole is going to be copper plated, and that's going to make it smaller. Instead, you generally want to drill the holes about 0.008 inches wider than you have to. So that would make this thing look like 0.02, and then our extra is going to be 8 to give us a little room. Then the next question comes in, do we need these pads to be really quite as big as they are? This looks like a pretty thick pad. A general rule for the pad size is it should be about twice the hole size. So if the holes are 0.28, the pad should be about 0.56. And that looks like a nice pad. Let's do the same thing over here. Properties. All right, that's everything for our first component. Save your work. Here's the component down here. Now, when you define these components, you'll probably be defining a great number of them at the same time. You'll be doing a lot of capacitors at once. To make your work faster, right-click the capacitor that you just selected and duplicate it. Rename it. Maybe you've got a 0.1 microfarad capacitor that's a different size. Might be in the FG18 outline size. And now redefine what's going on down here. Maybe the pad spacing on this, it's a smaller, is only 0.15. And then you can start to rework your silkscreen diagram right here. You can knock out a whole series of similar components very quickly this way. And this would be the same type of pad outline that you'd use for a resistor too.